Okay, so we're starting then today with compound interest, which is section 1.3. We'll start with the explore. So what are the next terms in this pattern and how do you know? So you should end up with $759.38 because each of these is going up by 1.5, or sorry, 150%, or timesing each one by 1.5. Then we've got some definitions to fill out. You can just check these definitions and make sure that you know this formula and go over it. And then we're going to start with example 1. We have Jared who earned $4,300 in overtime on a carpentry job. He invested the money in a 10-year Canada Savings bond that earned 3.8% interest compounded annually. He decided to invest instead of keeping the money in a savings account because the Canadian savings bond will earn more interest. What is the future value over 10 years? Okay, so we've got our formula, which is A equals P, 1 plus R over N times T. So our principal is $4,300. Our future value is what we're looking for. Our rate is 3.8%, which we always write as a decimal. It says it's compounded annually, so how many times a year is it compounded? Once. Annually means once. So N is 1, T, or time, is 10 years. So then what we can do is we always start inside the brackets. So we're going to go 0.038 divided by 1, which is 0.038, plus 1, which gives us 1.038 to the power of 1 times 10, or 10. Next, according to BEDMAS, we do exponent. So we go 1.038 to the power of 10. So when we go 1.038 to the power of 10, you get 1.45, which we then multiply by 4,300 to get a total of $6,243.70 would be the future value. All right, so example 2, we've got Stuart who has invested $23,000 of an inheritance in an account that earns 13.6%. That's a lot of percent. And that's compounded semi-annually, so 2 times a year. The interest rate is fixed for 10 years, and he plans to use the money for a down payment on a house in 5 to 10 years. So we want to compare the amount he'll have after 5 years to the amount he'll have after 10 years. So we're actually going to do the compound interest twice. So you can compare here the amount after 5 years and the amount after 10 years. What do you notice? Well, we notice that he about doubles his money after 5 years. And he over triples over 10 years. So remember that we have a simple interest future value formula that is A equals P plus PRT. So let's say that the principal is going to be the same, 23,000 plus 23,000 times your rate of 13.6% times your time of 5 years. Your future value in this case will be $15,640 in interest plus $23,000 of principal. So then you can compare that after 5 years your interest is $15,640 and 10 years it doubles to $31,280. But you can see that there's a big difference between your compound interest and your simple interest at 10 years. So example 3 then, we have Vesta who's 50 and she's got kids Josh and Kate who are 31 and 25 planning to invest $1,500 in an account with annual interest rate of 9% compounded monthly. If they keep their investments until they're all age 65, what will be the difference in the future values of their investment? So 9% compounded monthly, $1,500 is what they're putting in. So I'll do Vesta and then we'll split up for the other two. So Vesta is, we're looking for her future value. The principal is $1,500 times by 1 plus 9%. Monthly is 12. And 12 times, how long does Vesta have until she's 65? 15 years. So we'll first figure out 0.09 divided by 12. So the first thing we do here is, again, in the brackets, then we put it to the power of 180. So 3 times 3.84 times 1,500 gives us $5,757.07. All right, so now we've got Tyler, who invests $3,000 for a new car in the next 5 years. His options are 4.8% compounded annually, or semi-annually, monthly, weekly, or daily. We're going to compare the interest rate earned by each of these options for terms of 1 to 5 years. If you go 72 divided by the rate written as a percentage, this equals your doubling time. So this is a quick way to estimate when something will double. So for example, Chris invests $5,000, 8% compounded annually. Another thing to note is that the rule of 72 works best compounded annually. Okay. So we're going to estimate the doubling time and verify the estimate. So as an estimate, we could go 72 divided by 8, because that's your percentage, which is 9. So what this means is in approximately 9 years, it will double. Okay, but then we're going to verify this for 9 years and for 18 years. So to verify, we're going to plug it into our equation. So our principal is $5,000 times 1 plus 8% divided by 1, because it's annual, times 9 years. So if we figure this out, it's 5,000 times 1.08 to the power of 9, and you should get a future value of $10,859.50. So you'll notice that it is just more than doubled in that time. So that's why the rule of 72 is a good estimate. Try 18 on your own, the time of 18 years. And then all that's left for today is a homework assignment, page 30, number 2, 3, 5, 6, 10, and 11.